Hello again there, my good YouTubers. Welcome to my ham radio channel. 2E0FCZ, and today what we're looking at is my build of the VK5JST antenna tuner. Now I've done a couple of mods to this, obviously for, in my own, just because, well, I suppose we can do the mods. What I tend to use with the power is I use two 9-volt batteries in series strapped together, which obviously gives me the 18 volts. So I can use that, and obviously on standard batteries if I ever run out. Obviously I've put it in an aluminium box. We've got the serial programming input for the firmware on the side, on a 3.5mm gold-plated jack. We've got the power fuse, we've got the mode switch and the power switch. Obviously frequency selector, fine tuner, or frequency tuning and fine tuning here. I still got to work out an overlay, I don't know, with some like on photo paper or something like that, and then stick that onto here, or probably just here or whatever, to denote the values. Anyway, let's get it opened up and I'll show you what modifications I've done to this personally. I wanted to use a regulated or extend the regulator circuit on this. The standard linear regulator was obviously the a bog standard. Now I wanted to change it out and use a low dropout voltage regulator, and I had a few problems with because I used a Micrel Super Beta low LDO, and oddly enough that has a couple of little tricks to it that you have to know, which was not in the PDF datasheet about the unit. But so here we are. This is my VK5JST build. I'll take the serial connector off so we can actually open it up and take a good look at it. Now what we've got in here, obviously, as I say, I run a coax cable as shortish as possible, basically, from the board. I didn't bother using the banana plug terminal pins, but this is my little adapted circuit board here for the VK5JST antenna analyzer. And what I've got here is I've got two low dropout voltage regulators printed on my own little PCB board, and basically what this does is it regulates the 5 volts and the 12 volt supply to the board. So no matter what particular voltage you enter or you put in through the power socket, obviously not excessive, we're only talking like a maximum of 20 volts for instance, then the circuit or the antenna tuner will always see 12 volts and 5 volts, give or take the point values of plus or minus 2%. I believe it is 2% or 5%. Because the low dropout. Now you'd think, well, what's with the rest of the components on here, because LDOs pretty much don't need that many external components. Well, in fact on this, the small components here, obviously filtering capacitors. We have a diode, which is for reverse polarity protection. So basically if you get the polarity wrong way around here, it literally just blows the fuse. So that's an easy way to do reverse polarity protection. We've also got, in case these two rectifiers fail, we have an overvolt protection, so it doesn't damage the actual antenna tuning circuit. So these basically are Zener diodes set at particular voltages, so that if these decide to go overvolt, then it shunts it to ground, blows the fuse again, and protects the main circuit. I've also modified and used a much more accurate crystal here, and I've put that on little tiny standoffs, like a plug standoff, so the crystal can be plugged in and out rather than actually have it soldered to the board. Furthermore, the little tricks that you have to do with these Mackerel type regulators is they won't work unless they're actually draining a minimum on the 5 volt of 6 microamps and milliamps, and on the 12 volt it needs to be 7 milliamps. So what I've added here is I've added a 9 milliamp and 9 milliamp load of 2 small LEDs, obviously with their adjacent resistors to resistor them down to the correct, the lowest possible current rate as I can think of, and that's what keeps these operating, and therefore keeps the circuit unified. Now again, the problem is, if you didn't have this small load in here and this constant load, what would actually happen is these regulators would act like a straight short. They wouldn't actually regulate the voltage, and the circuit here would see whatever voltage it is that is being applied to the actual unit, and obviously we don't want that. So to make sure of that, obviously I have made the LEDs as a load here to make sure that it's always pulling that current, and these always remain high, and hence the other reason for the Zener diodes. If these fail, then obviously the Zener diodes basically shunt the power to ground, and obviously keep the voltage through the circuit, or keep it all from damaging any other part of the circuit, and obviously blows the fuse and so on and so forth, and obviously leads you to the area where you need to repair it. Now everything else pretty much is the same circuit. I've upgraded the firmware. I've did a few little tweaks or whatever to the actual code of the software. One of the major operations that I had to do to improve this was in between here I used board pins, which is when you put 2 boards together. The pins, you get a socket on one board and pins on the other, and that's what I used between the LCD screen and the PCB. Now in the normal kit you would just use wires to this. Other people have used ribbon cables, other people have used ribbon cable type connectors with a bit of ribbon cable. I obviously wanted to use straight pins, and because I was using a solid aluminium case, the standoffs and everything, you've got to get the line up correctly, and it's able to slot on easily and effectively. So this is my version of the VK5JST antenna analyzer. Again, I also like the fact that using an aluminium case acts as a good shielding method for it. Now I've tested this in the field and calibrated it, and it works exceptionally well, should I say. Very impressed with this, actually, in a matter of fact. And yeah, it's I'm very happy with it. I'm very happy with the job that I've done on it, and so on and so forth. But let's reconnect those 2 units there, or those 2 connectors there, and we'll stick 1 screw in it, and then we shall power it on. And you can actually see firsthand the unit actually powered on and operating. Now again, I used 2 9-volt batteries strapped together, obviously with a DC jack connector, and I don't know whether the camera's going to pick this up. As you can see, we've got battery ready voltage 12.2s, we've got my alias and core name, and then we have the actual unit kicked in. And because this provides us with I don't know whether you can see that in the camera, obviously with an LCD, this isn't a backlit LCD, so a bit of a fortunate, but we can change to different modes here on the frequencies to see the swirls, the resistance, we've got inductance, reactance, we can switch further, Obviously, as I say, we've got out of range because there's nothing connected to the antenna at the moment, or the antenna socket. We have, obviously, these values not showing anything because there's nothing connected, so there's nothing coming back on the feedback for the circuit, which does pretty much most of the mathematics for us. But as you can see, we have a very nice working analyzer which works very, very, very well. I've used it on the field several times, and works perfectly. So this is just a quick video introduction to my channel, or new ham radio channel for ham radio stuff. And this is my VK5JST, which isn't finished. As I say, I've got to do the labels to it and things like that. But incredibly good circuit design, very well done by VK5JST, and one hell of a useful tool at not even a quarter of the price of a commercial product. So thanks a lot for watching, my good YouTubers. I hope you enjoyed the video. I hope you've seen a couple of tips and tricks in there that you would like to probably try yourself if you want to try your hand at building one of these as well. You get these from the office website, or his club's website, which is obviously based in Australia. And really, even including all the customs charges and everything to bring over to the UK, it really isn't that expensive. It actually comes out at a very good price. So anyway, thanks a lot, my good YouTubers. Have a good one, and just 2E0 Foxtrot Charlie Zulu 7 3s. Have a good one.